All right, we'll get started. Okay, one order of business is the final exam. The room numbers aren't on the sheet, so they're here on Moodle at the end. And we have two rooms. So based on your last name, family name, surname, you'll either go to one of the two rooms as assigned. Okay, are there questions before we get into the material? Yeah.
So for the Facebook and some example that you give where a person likes an article and it goes to Facebook.
Yeah.
So do we assume that the person is logged into Facebook already? Or?
Yes, exactly. So they have to be logged in. Otherwise, it doesn't work.
Okay. Similarly, the bank one.
That as well. Yeah. So cross-site requests only work if you're logged in.
So does it have to be like simultaneously in another browser or same browser something?
There's no simultaneous assumption. It's just that the thing to recognize is that when that request goes out, your cookie's thrown in. So the website receives it with the cookie. And if the website thinks anyone showing up with this cookie is considered logged in, then it will log you in.
Okay. Also, in the Firesheet request,
Yeah.
the Firesheet extension.
Yeah.
So I was wondering, how do they see the traffic? Because like essentially you're supposed to log in and then you have cookie, you have like credentials. But if there is a person who is intercepting the traffic, I was wondering like how does it make them actually see the interface that actual user is seeing?
Okay, so the Firesheep extension first will poison the router table for the Wi-Fi router. So it will get everyone's traffic flowing through your computer. So you'll see a copy of it. So basically, you're like a proxy. So they send a message to Facebook. It goes to your computer. You send it off to Facebook. And then similarly on the way back. Yeah? So right now, you're not doing anything with the traffic. It's just sort of flowing through your computer. So you can look at it. Then if there's no HTTPS, then you'll see the cookie values in the headers being sent back and forth. Yeah? So what I can do is I can lift your cookie out, put it in a URL, and then I go visit Facebook with your cookie, and then now I'm logged in as you. Or Facebook looks at the cookie and says, I know that's you. I know that you're logged in, so I'll send you back your home screen with you logged in.
So there's no need for credentials?
Yeah, so there's no need for passwords or anything like that. And it doesn't help you steal passwords because the passwords themselves were sent over HTTPS. It was just once you logged into the site, they would transfer you back to HTTP, but they would maintain your session with a cookie value. Does that make sense?
Yeah, a little bit. Also, you mentioned that in the boarding pass,
Mm-hmm.
the barcode is not big enough to have a signature.
Yeah.
Do you know if there's a real life example where you actually have barcodes with signatures?
You know one? Yeah.
Maybe, I'm not sure. It's back in France when it was COVID time and that we get the vaccinated.
Yeah.
Vaccinated, we
Right.
have like a QR code, a big one,
Right.
and I guess that one's signed.
Yeah, that actually is a good example. Yeah, so maybe the QR codes for COVID vaccines were signed. They are substantially bigger. I think I still have mine on my phone. I'll just see if I do. So this isn't going to be that useful, but you can see it's a substantially bigger one. So yeah. So that's a good point. So it could be. I don't know for sure that it's signed or what. I'm not sure what the signature thing is on it, but I assume that if they weren't signed, people would have been creating fake ones, and I didn't hear any news stories about people creating fake ones. So, yeah. Okay, other questions? Okay, so we'll go into the last lecture. Okay, so this is a continuation again of security policies. Okay, so you'll recall that a lot of browser policies were set in the 90s. The web today looks different than it looked in the 90s, but once you sort of set policies, you can change them. So there are changes that have been made, for example, not allowing JavaScript to come over an insecure connection. But anyways, whatever change you make breaks a lot of existing websites. And so browsers are sort of hesitant to make changes. They would prefer people get the right mental model of how everything works, and they find their own solutions. So for example, cross-site request forgery, that's sort of a breakdown in your mental model of how the web works and how requests come. And there was a simple solution to it, which is just that we sort of throw the cookie in the URL parameter. Okay, so that's what browsers prefer, is people figure it out that way. And then because a lot of people don't code a website from scratch, you're going to use some sort of library. As long as the libraries put these protections in, then you don't have to worry about it as a web developer yourself. So two of the most important policies, the two that we're talking about, are the cookie policy and something called the same origin policy. They're related to each other. They both concern origins. But you can think of the cookie policy as being about cookies and the same origin policy being for active content, in particular scripting like JavaScript. So recall from last class, we have the content of the page, which could be passive, so the HTML itself, images, video, audio, or it could be active, so that includes scripting and a few other things. And then in addition to the content, you have the meta content, the stuff that's in the headers, so that would include where cookies are. So last class, we talked about cookies specifically, so that was something that's in the header. Now we're going to talk about scripting, which is part of the web page itself, and it's active content. Okay, so the same origin policy, the purpose of it is to try and figure out what happens when you start blending content from a bunch of different places into a single website. Okay, so the user is still seen in the URL address, the URL of the root page that got downloaded, but the actual content of the website may have come from that page, or it may have come from other places on the web, and the user doesn't know that you're weaving together all of this content. Okay, and the browser has to figure out, in particular, because resources that are active, like JavaScript, can talk to other resources that are running on the same page in the same context. Okay, so the browser has to figure out, are we going to isolate these resources so they can't talk to each other, or are we going to let them talk to each other? Are we going to let them read each other? Are we going to let them see each other? Right? So for example, if I have a Facebook like button somewhere on my page, Facebook is doing something on my page. I'm asking a username for their password, right? Does that mean Facebook can read that password? You know, so those are the kinds of questions that we need to answer. Okay, so basically what your browser does is you go to a website and it gets a list of resources, and what it's going to do is it's going to tag all those resources with basically what's called the origin of that. Okay, so roughly we'll pencil it in as where it's from, but it might be slightly different as we'll see. Then what we do is we store them. So the browser kind of renders the page in this sort of data structure. It's called the DOM tree. The details don't really matter. The main thing is that if you're running JavaScript can go into this tree and they can kind of look at the other resources that are in this tree, or they can actually ask for changes to be made. Okay, so scripting has the ability to sort of modify the contents of the website, and that's because the browser's giving the script basically what's on the website in a data structure that the scripting can traverse. Okay, so active content like scripts may be accessed. Well, they are able to access it, but there's going to be a few caveats in terms of origins. They're going to be able to both read and write from the DOM tree. In other words, if you have a script and you have an image, the script can see what that image is. It could replace that image with a different image, whatever. Okay. All right, so the basic story here is that if you get one bad script running on your page, it has the potential to rewrite the entire website that the user is seeing in their browser. Okay, so your browser might initially download a clean version just while the JavaScript is sort of firing up, but then once it starts running, it could just rewrite everything, and that can happen so fast that you don't even notice it. Okay, so you'll be looking at what looks like a totally different website in terms of the content of the page because it was completely overwritten by a bad script. Okay, so let's drill into this idea of resources are tagged with the origin they're received from. So first off, an origin very simply is just the protocol domain and port that it was received. And there's this override flag that we'll talk about later. So for example, an origin, what it looks like just semantically is, for example, a domain like test.pulpsci.com. So that includes subdomains. The protocol that we got that resource from, so if we got over HTTP, then it would also come over port 80 because HTTP served over 80. If it was SSL, it would be HTTPS in port 443. And then there's this flag thing that you don't have to worry about yet. Okay, the definition of what does it mean for two origins to be the same is they have to be the same in all four of those categories. Okay, so if the domain is slightly different, for example, it's a different subdomain, it's not the same origin. If you get one origin that came over HTTPS and one origin that came over HTTP, they're not the same origin. Okay, so same origin means everything about it is the same. If everything about it is the same, then it's considered the same. Otherwise, it's considered not the same. All right, now let's say you want to change the origin. So for example, let's say that you're at test.pulpspy.com, but you want your origin to just be pulpspy.com. Okay, you can change it. So that's what that flag is. And so basically you can move up. So if you're a subdomain, you can move up to the parent domain, but you can't go all the way up to .com. You can just go up to the top, or sorry, the domain itself. The way you do it is you just tell the website, you have a line like set document domain equals pulpspy.com. And then once you do it, it flips that flag in the end of the tuple. So it flips this flag from false to true. Okay, so now this just means the origin here is pulpspy.com because it was overwritten. And the fact that you're looking at this means that the browser checked it out and thought that it was okay for whoever the true origin of this is, for them to flip that. Now, this won't necessarily match to everything at pulpspy.com, okay, because there might be stuff that comes over from pulpspy.com over HTTP, over port 80, but it didn't set the flag itself. Okay, so technically, if you want to interact with everything that set the flag, you have to set the flag yourself, even if you are the thing that they're setting the flag to. Okay, so just some examples here. So you have a bunch of different URLs. So what here is sort of the same origin and what's different? So the first two, you'll see they're the same protocol. The subdomain is exactly the same. So they're the same origin. Here, the protocol changes. So this would not be the same origin as, say, the first one. This one, the subdomain is completely different. So it wouldn't be the same origin as the first one. And similarly, this is a super domain of the first one, but they're not the same origin. However, the first one, if it wanted to, it could set its origin to be encs.concordia.ca. That's within its rights. Then it would match with this one, but right now it's not matching. Okay, so these are the same. And the rest of them are not the same. And if this one wanted to match this one, then it could set its document domain to be encs.concordia.ca. That's fine. But right now it's not the same because this one hasn't set the flag as well. Okay, so even though this one is encs.concordia.ca, its flag is false because it hasn't overwritten it. Okay, so to make them the same, it would have to also set it. It seems kind of stupid because its domain is already this. Why are you setting it to the same domain as yourself? But it's just to get that flag set. And then once the flag is set, now these are actually the same origin. Okay? And so you're going to have privileges. I didn't motivate it well, but like why do you want to be the same origin as something else? The idea is that you can talk to resources. So resources can talk to each other if they're the same origin. And then sometimes you don't want to be the same origin as someone else because you want to isolate your resources. So in that case, you wouldn't override. Okay. A lot of people, like web developers, when they're trying to get things working, they're going to throw security out the window. Security is their secondary goal. And so they'll just set domain to always be the top domain that's allowed. So everything will get set to concordia.ca all over the website. So that's kind of the most permissive thing that you can do. It's kind of bad on security. You're not really thinking through, do I want these things isolated or not? But from a debugging perspective, that's the easiest thing to do so that everything has the potential to talk to everything else. Yeah.
In slide 6 you said in the origin contains, you mentioned port.
Yep.
How does this change in kind of origins, or if it does?
Sure. So generally URLs don't include a port, but you can put it in to a port manually. So like if you can write a URL, you can specify like a custom port, right? So the notation would be like a colon and then the port. So because this is HTTPS goes over this port anyways, right? But you could have a URL where this goes over port 68 for whatever reason, right? And then this isn't going to load. But then it would be assigned an origin with that port.
So it's going to be a different origin.
Yeah, it would be a different origin from any other link that either, like, maybe I'm not explaining this well. You could not include a port at all. Yeah, so let's say you don't say anything about the port. It's going to be the default port. So the default port will either be 80 if it's HTTP or 443 if it's HTTPS. If you're doing any other port, you can manually put it in. Now your browser might be like, I don't speak that port, right? So it might not like it anyways. But anyways, it will assign it with that origin, and then it will do its best to try and reach something that's going over that port. But it would require the user to have installed an extension or an add-on or something to catch anything directed to that port and then send it usually to a custom application, right? Yeah, like BitTorrent or something like that. Okay. Okay, so this is the theory of what a same origin is and all of that type of stuff. Now let's see how do you actually get an origin? Like what's being assigned an origin and how? Okay, so we're going to concentrate just on scripts. That's the main thing we're concerned about, but this applies to any active content. Okay, so there's different ways. So the basic question is, how do you get a script into your website in the first place? So there's different ways that you can do it. The simplest, most direct way is you can actually just put it in the HTML itself. So HTML includes a script tag. So you open it with script, you end it with /script, and then you just dump your source code there, and then the website will execute that. Okay. Now, let's say that the user's visiting concordia.ca. The visitor's doing this over SSL port 443, and this script is in line. It's in the, say, the index.html of this particular website. What origin is it going to be assigned?
Concordia.ca.
Okay, so it's going to be concordia.ca. So not a trick question. Okay, so the origin, I'm not putting in that longer notation, but it's basically going to be this. Okay, now let's think about another way of getting a script in. What we might do is we might embed it. Okay, so we have the scripting file. It's sitting in a JS file somewhere else, and we're going to pull it in and embed it. Okay, so again, we can use the script tag, but instead of putting the source code in the script, what we do is we point the tag at where it's from. Here, the script is coming from concordia.ca. We're on the website concordia.ca. Both are being served over HTTPS. What's the origin that's going to be assigned to this script, do you think? Okay, that's the file name, but the origin itself, so concordia.ca. Okay, so there's not really any other answer that's possible. Okay, so this is we can call it a same site script because the place that the script is hosted and the website that you're on are the same. Okay, now another thing you might have heard of is cross-site scripting, particularly because there's an attack that's based on it. Okay, now just like cross-site requests, those aren't bad. Cross-site request forgeries are bad. Cross-site scripting is not bad, right? It's how the web works. But cross-site scripting attacks are bad, okay? So this has nothing to do with the attacks yet. But anyways, so cross-site script very simply means you're on the website concordia.ca, but the script file that we're loading, lang.js, is not from concordia.ca. It's from a different website, okay? So for example, it might be on GitHub. Okay, so let's say we pull this script in from GitHub and we put it into the website. What origin is the browser going to assign to the script?
You're pulling it in, so it's going to be Concordia.
Okay, but
you are still in Concordia.
Okay, so that's one idea, is that you are pulling it into Concordia's website, so the origin of the script is Concordia. Any other ideas? Okay, so we're pulling it from github.com, so it could be github.com. All right, so let's say it's 1994, we're all working at Netscape, and Netscape comes to you and says, do you want to assign origins that look like this to concordia.ca or github.com? Those are your choices. So who wants it assigned to concordia.ca? Who wants it assigned to github.com? Okay, a few people. Who doesn't care? Okay, now let me ask a flip question. What do you think? Do you think it's concordia.ca? Show of hands. Be brave. GitHub, show of hands, be brave. Okay, so I would say that the natural thing, if you don't think it through, is probably you're going to think it's github.com, right? That's the origin of where this file is coming from. But the correct answer is actually concordia.ca. Okay? And it's this simple mismatch between what you think and what actually happens that has created all sorts of problems in terms of cross-site scripting, okay? It took developers a really long time to sort of wrap their heads around this. The fact that if you pull a script in, it runs with the permissions of the website that's calling the script or embedding it rather than where you're actually getting it from. Now, if you pause for a second, it kind of makes sense. If I pull this script into concordia.ca, right, it happens to be at github.com. Should this script be able to change things? Like say I load an ad from github.com or something else. Should this script be able to go and change that because it's also from github.com? No. Or if I load two scripts from github.com, should they be able to talk to each other? Or should this be able to talk to GitHub's domain in general? No, right? So the mental model to think of this is, it's like you go to that URL, you open up lang.js, you select that whole file, you hit Control Copy, and then you dump it between the two scripts. And you hit Paste, and then you hit Enter. If I dump the code between the two scripts, we already said that that's going to have origin concordia.ca. Okay? So this is no different than that, other than the file just happens to be hosted on github.com. That's where the copy of the file is, okay? But it's like I'm taking that file, I'm copying and pasting it into the source code of my HTML when I make a call like that, okay? And so because I'm taking that code and putting it in my website, it's going to run as if I just coded it myself on the website. Okay, so it's as if the script was copy and pasted into between the script things. And so scripts with the same origin share they share everything. So everything in the DOM tree, all the other resources on the website, if you're the same origin as another resource, you can access it. You can read it, you can write it. If you're a different origin, then you can't do it. Okay? Now, most people would, for example, this is called lang.js. Okay? So maybe this, like, it's a language library, you kind of pull it in, and then it gives the user some settings, like maybe they can choose between English and French. And let's say the default is French, but the user clicks on English. Then this script might go and rewrite the website in English. Okay? So it should have access to the website. It needs access to the content in order to do this. Okay? But it can't have access unless if it's the same origin as the website itself. Okay? So just because GitHub is the host of that file doesn't mean it runs with GitHub's permission. Okay, it's not running in the context of all the GitHub stuff on the website. You're pulling it in. It's like you're copy and pasting it in, and it's going to be able to interact with the rest of your website, which is probably what you want anyways. Okay, so that's the motivation for why cross-site scripts are assigned the origin of whoever calls them rather than the origin of where they're actually from. Okay, and then just as a caution, scripts are very powerful, right? So if they can access things, they can rewrite things. If there's a password field where a user types a password in, they could have access to that field if they're the same origin as the HTML that's creating it. Or they could, through JavaScript, start running like keystroke loggers or things like that. They may have some ability to pull off cookies. Cookies that are affiliated with the same origin that the script is running. So anyway, so these are things that you need to be aware of. So JavaScript is very powerful. And if you get bad JavaScript running on your website, then it can do a lot of damage, at least for the user that's looking at it. Okay, now here's another example. So this is called an iframe. So an iframe is kind of like a box that you can draw in a website. And so you define it as iframe, and then you tell basically your browser, this website is going to fill this box in. Okay? So facebook.com, add.html, you're basically everything that's inside this box is going to be populated by the HTML file add.html, which is being given to you by Facebook. Now, let's say that Facebook, in this HTML file, they start running some JavaScript. Okay? So the JavaScript is sort of inside this iframe. Okay? So we have some JavaScript running here. All right? What's the origin for this JavaScript? Is it facebook.com because it's in Facebook's iframe? Or is it concordia.ca because it's in Concordia's website? Okay. So who thinks Facebook? Who thinks it should be Facebook? Okay, who thinks Concordia? Who thinks it should be Concordia? Okay, so this will run with origin Facebook. Okay, so this is how you basically can embed scripts that are cross-site and have them keep the origin of the cross-domain. And it also is going to provide some isolation of this script, okay? Because the origin of the script running in the iframe is different than the origin of all the stuff that's running out of the iframe, they basically can't talk to each other, okay? So the script here can't read anything that's outside of the iframe. It can't overwrite anything that's outside of the iframe. Similarly, if you have scripts that are running outside of the iframe, you can't reach into the iframe and do stuff to what's in the iframe itself. So for example, let's say there's a like button that Facebook puts there. Concordia can't write a script that reaches into the iframe and presses the like button. Okay, it can't see it. It can give the iframe to Facebook, and that's all it can do. It can just say, here's your iframe, here's the size of it, you know, and then it doesn't see or touch anything that happens inside of it. There could be a password field that's in here for you to log into Facebook. Concordia would not be able to read that password. Okay, so iframes are the way that you can embed resources and isolate them from things that aren't in the iframe. Okay, so Facebook can't reach out of the iframe to Concordia. Concordia can't reach into the iframe to Facebook. Reach in this case means both read and write. And so resources from both of the origins are isolated from each other. Now, let's say they do want to talk to each other. Okay, so maybe this is an ad and this is like an article, and the article wants to pass in like what article ID it is, so the ad is more relevant to the article or something like that. First off, you could do that in the URL itself. That would be the more common way of doing it. Because you're loading the iframe, you're specifying, you in this case Concordia, they're specifying the URL so they could pass in whatever parameters they want. But if you do want to, if you want resources to talk to each other, it's possible. What happens is it's not that you get access to the complete DOM tree for the other side. Okay, but what happens is there's a protocol where you can write messages and the other side can read it, and then you can exchange messages back and forth. So it's called post message. Both sides have to authorize it. So if one does it and the other doesn't, then the messages don't go through. So the browser will only pass the messages if both of them authorize it. They have to say explicitly what the other domain is. So Concordia would say, I want to talk to https facebook.com, and Facebook has to say, I want to talk to https concordia.ca. Then you can pass messages back and forth. Okay, so you may have heard of cross-site scripting attacks. Okay, and so these attacks work because this stuff is kind of complicated, and the policy also maybe isn't what you think it is in terms of what origins things are assigned. Okay, now cross-site scripting is really a big umbrella of attacks. So there's probably 10, 20 different variants of cross-site scripting, or attacks that use cross-site scripting as one subcomponent of the attack. So since, first off, you'll take a networking course at some point if you haven't already. And I think in that course, they'll show you lots of different kinds of attacks. So my purpose isn't to like teach you cross-site scripting or how to do it or anything like that. But what I want to do is I want to show you some examples so you can see how the policy of how you assign origins what it has to do with these attacks themselves. Okay, so we're going to look at it at a much higher level. We're not going to go into the technical details, but I just want you to see why the policy leads to these attacks being possible. So I'll show you a handful of these attacks. Okay, so probably the most common way to do cross-site scripting, or the easiest, lowest bar, would be almost like a social engineering attack, which is, let's say you find some super popular JavaScript library. It's being hosted at some third-party site like GitHub. And there's lots and lots of websites around the world that pull in that JavaScript because it's super useful. If somehow you're able to poison that JavaScript file with your own custom code, then every website that pulls that JavaScript in is going to run your code in the context of that website. Okay? And then you can do whatever you want to the website. So you can read things, you can write things, try and steal cookies, whatever you want to do. Okay, so if you're able to hack a popular JavaScript library, that's one way that you can use cross-site scripting to attack other websites. You're not attacking GitHub in this case, you're attacking all the websites that are pulling in that JavaScript from GitHub, okay? What stops you from going and changing this file on GitHub? Usually a username password, right? Like someone owns the file, someone wrote it in the first place, and they have a username password set up. And if you can break into that account somehow, right? We saw in social engineering, there's lots of different ways of breaking into accounts. We saw ways to steal a Twitter account. Stealing GitHub is similar to stealing Twitter. Any of those types of attacks work. Then you can change that file. Okay, another thing is, let's say that the person was pulling in the file over HTTP and you happen to be in the middle. What could you do? Okay, you can intercept it. You can just change the file on the fly. Okay, you can completely change it. You can add your code into it or whatever. Okay, now your corrupted file will be running inside the context of Concordia.ca, so you can own whatever the user is doing with Concordia.ca. All right, this is why we now block any JavaScript that's run, that's fetched over HTTP. So we just straight up block it. The browser will not accept it. It won't even put out the request to get it. And so it's because it's so dangerous to do. Another thing, I've said it before, I've sort of hinted at it, but I just want to really reiterate it. Let's say this attack were possible. I want to emphasize that you're not changing Concordia.ca itself. Okay, so Concordia.ca has a server, it has a bunch of HTML files that it sends down to users when they ask for them. Okay, you're not changing what's happening on the server. You're not changing what's being sent from the server down to the user. What you're changing is when the user basically pulls all the stuff in and displays something, when the browser pulls all the stuff in and displays it to the user, that's where you're changing things, okay? So Concordia.ca is still pristine. You didn't hack the server, you didn't change the website itself, you're just changing how the user experiences the website, more or less, okay? So if you are able to intercept some users that are loading this library, you can kind of break their experience with this website. But if there's other users that aren't going through you, they're going to get the normal website itself, okay? Whereas if you could change the server itself, then you could change everyone's website, okay? So cross-site scripting attacks tend to be that way. You're attacking a specific user and their browser rather than the server itself. But yeah. Okay, the sort of original cross-site scripting attack was that you have a website. For example, let's say it's a profile website, and there's some text that you're allowed to put into your profile, and you can hit save. Okay, so what people would do is they would put scripting, HTML script files into that profile. They would hit save. Now, if someone goes to that profile and looks at it, then they'll see, they won't see it, but their browser will see the fact that there's a script sitting there in the profile. And what you're relying on is that the browser confuses that. It doesn't know that that's text to be displayed to the user. It thinks that's HTML for it to run. Okay? So the browser is just parsing it. It's going to display it to the user. And then when it hits a script tag, it's like, oh, that's a script. I gotta execute what's inside this script itself. Okay? So that's the classic kind of cross-site scripting. It's called persistent cross-site scripting because you're storing the bad script on a website permanently. And in order to get it to exploit a user, you have to have the user visit, for example, your profile. And then it only breaks that profile website. So I'm looking at this profile, the script starts running. And so as you're looking at my profile, then it's going to destroy the context of looking at the profile. But it may be able to do things like, for example, get you to follow me because I can launch that request from my script, and your cookie, because you're logged in, will go along with that request. Okay? So you can combine, once you have a cross-site script running that's malicious, then you can start doing cross-site requests, or forgeries in this case, to different websites. Okay? So one of the original attacks using cross-site scripting was on social media. someone created a profile that had a script that would basically, if you looked at their profile, it would force you to follow them. And then it would also force you to change your profile to include the malicious script on your profile, right? So 10 people looked at this person's profile, all of their profiles updated with the same malicious script that would make you follow the original person. Then maybe 100 people look at those 10 people's profiles and all of their profiles update and everybody's following the original person, okay? And then it spread right across the social media site and it created so much extra traffic that the whole site came down. I think it was MySpace, I can't remember. It's like one of these like early kind of social media kinds of things. I believe also the person like was criminally charged for doing that, but okay. All right, so what do you need in order for this attack to work? What you need is a place where users can store a string, and that string is reflected to different users other than themselves. Okay, so I go to a website, I store a string, but when you go to the same website, you see the string that I store. Okay, then you also need the browser to confuse text with code. So it's going to hit this line of text, and instead of displaying it to the user, it's going to think, oh, I need to run that. Okay, and so how websites defend against this is they do a lot of sanitization of user input. So they might say like a triangle bracket is not allowed. That's not an allowed character, okay? And then they also do a lot of work on ensuring that the way it's displayed to the user is as text and it won't be confused as code, okay? Obviously you can write an HTML page, like say, you write a website teaching people how to code in HTML, you're going to have a bunch of triangle brackets, and those somehow they're not being executed by the browser thinking it's supposed to execute them, okay? So there are ways for browsers or websites to say this is information to be displayed, it's not to be executed itself, okay? And in general, if you code a website, you're not going to do it from scratch, so you're going to get a WebKit, and the WebKit is going to have, 5 or 10 years of engineers like poring over every like input field in the entire framework from start to finish, making sure that they're all hardened against cross-site scripting. Okay, so these kinds of attacks now are rare. It basically would only work if somebody hard-coded a website themselves and didn't take any extra measures to sort of protect against this. Okay, another kind of cross-site scripting is something like this. So let's pretend we have a URL like google.com. We have search, we have a query. We saw these query strings before. And in this case, we embed the script in the query string itself. Okay. Now, I send this link to you in an email or something like that, and somehow I trick you on clicking on it. Okay. So what happens when you click on this link? Okay, but how does it get executed? Just because it's in the URL doesn't, we want the JavaScript in the page. We don't want it in the URL.
It's a reflected cross-site scripting that it will run, it will pull the resources from the mentioned code and run the code.
It will put the resources where?
Source mentioned in the code.
Why? Okay, so it's true JavaScript. Okay, browsers are allowed to run JavaScript. If this script were in the body of the page, then it would run. So I agree with all of that. But this isn't, it's in the URL. So how's it getting from the URL into the body of the website?
Because the code is using it as a parameter. The queue is using it as a parameter.
Yeah, so the queue is that it's a query, you're going to search for it.
Exactly. But since you're using the HTML headers, then in the code is going to read it as a script.
Okay, it won't read URL parameters as scripts.
It will pass in the search page as a query.
Okay.
It's not sanitized, it will run as a...
All right, so you pass it as a query, then Google queries their backend SQL database with this weird script thing, right? And then it says, oh, there's no results. And then it just shows you a website that says, oh, there's no results. but it didn't run in the user's browser. You're very close. I'm teasing a bit.
But it ran in the query data.
Yeah, so Google will run this. Maybe there's some SQL injection attack where you're attacking Google querying it, but that's not what this is. We're trying to infect the user themselves.
Google returned the query like no such result found.
Yep,
When response came back to the browser,
yep.
browser run the executor script.
Okay, so what if the browser decides that there's no results displayed? Instead of saying there's 0 results found, it would say there's 0 results for, and then it would just repeat the query that you searched for, okay? Then now it's in the body of the website itself, okay? So it might say, sorry, there's no results for, and then say script code dash script. This is now in the context of the website, and then it would have the chance of running in this case, okay? So this works because of the way Google would be coded. So because Google is coded in such a way that it takes certain parameters from the URL and under certain conditions would display it in the page, you have a chance to, we call it reflect. So we reflect things that are in the URL into the page itself. Then what we do is we jam some scripting in the URL, and then we try and trigger the condition where the website's going to copy what's in the URL and put it in the body of the page, and then hope, again, that it confuses text with code. Yeah. So, for example, Google does this, but it's not, it's completely sanitized. So there's not an attack here, but you can see if I click on a URL, it was kind of small to get it to fit. But the search query is a script. There's not going to be any search results probably for that script anyways. And so it's going to tell you something like, oh, there's 0 results. But when it says there's 0 results, it does actually repeat exactly what you passed in. Okay. It also, for good measure, puts it up here in the search bar itself. Okay. Now I didn't go to Google and search that. I just clicked on a link. Okay. That's all I did there is I just clicked on the link because this was embedded in the link itself. At the end of the link, it grabbed that out of the URL, embedded it in the body of the website. And so this would have been a chance for me to have my script executed. Google sanitized it. That's good on Google, but not every website's going to do that, okay? So there could be websites that are, again, maybe like not programmed with the latest like WebKits and things like that, that would allow that to go into the body unsanitized, and then you would actually run the scripting itself. Okay, questions so far? Okay, now I'm going to show you probably like a very elaborate attack. So these are some of the more basic ways of doing it. And then I just want to show you an example just to show you the sort of extreme measures that attackers will go to in order to use attacks. I mean, if there's an attack there and you can do it, it doesn't matter how complicated it is, right? You're going to do the attack as long as it works in the end. Okay, so what happened is at first, people who wrote these web frameworks and anyone who was writing a website from scratch, they spent a lot of time on looking for cases where the user could input a string and it would be shown to a different user other than themselves. Okay, so like a profile, like I changed my profile, then when you click on my profile, you see the text that I wrote. Okay, so that was sort of the condition. So they would pour through the source code looking for, and you can use taint analysis and different kinds of automatic tools to see like, could something the user types in here ever be shown to another user? Okay, and then you would go through and you would sanitize all of those things. And so eventually we got to the point where there wasn't any cross-site scripting, persistent cross-site scripting left anymore. Okay, so there was nothing to do. All the websites were hardened against it. But there was one place where websites weren't hardened, which is there were some places where users could input text, but it would only be shown right back to the same user. So for example, you might type in your email, and it would only be displayed for you. It doesn't go part of your public profile. If I log in with my account and I go to the right tab, and it will show me what my email is. So it will store that information. It will send it back to me. That seemed like low priority. We didn't have to really harden it against cross-site scripting, because what's the worst that would happen? I put some script into that text field, right? But I'm the only one that can see it. So I go to the profile and then I infect myself, right? It's like I can only attack myself with it because it's only information being shown to myself, okay? I couldn't use it to attack you. And so because of that, people just weren't that concerned about these interfaces, okay? So there's a bunch of stuff like administration panels and backends and things like that where it's a bunch of information that's taken from the user, stored on the website, but it's only shown back to the user. It's not shown to anyone other than the user. All right, so people want to exploit this. They thought, well, we found this cross-site scripting. Yeah, we can only attack ourselves with it, but is there really nothing we can do with this? It seems like there's the potential there for an attack. I mean, we can get the script on there and we can get it running. So like, can we actually like do this somehow? Okay, so this attack involves a combination of cross-site scripting and cross-site request forgery. And the way it works is like this. The adversary sets up a website, call it evil.com. They have to trick the user into going to the website somehow. So the attack has to start with like an email sent to the user or something like that. They click on the link. But in general, you shouldn't, you should be able to more or less click on any link and not have bad things happen. I mean, the worst that could happen is maybe, well, anyways, I don't know. The web model should limit your ability to have bad things happen to you by clicking on a link. But anyways. Okay, so the user has to click on this link, so they're going to do it. Now, what the adversary has on this website is they're going to use some iframes. They're going to use more than one. Okay, so they're going to open a first iframe. Okay, and the iframe is going to be, say, to a website like Twitter, where it has one of these vulnerabilities, but it's in messages that are only displayed to the user that's logged in. Okay? So they open it up to Twitter, and at this point, if the user happens to be logged into Twitter, then when they go and load the iframe, they'll send their cookies along, and then Twitter will send back information, and it could be like their profile, like their direct messages, whatever information it is. Now, right now, it's sitting in the iframe. We said that iframes are isolated, so the adversary can't reach into that iframe and pull that information out. So let's assume that that's the adversary's goal. The adversary wants to read your DMs on Twitter. Okay? They can't do it even if your DMs are sitting there. They could be sitting there visible. They can set up an iframe that loads the page that has your DMs in it. Okay? They can have your DMs sitting there, but they can't reach across because this is a different origin than the website itself. Okay? All right. So then what they do is they open a second iframe. Okay? And assuming that you can do stuff through URL parameters, like a RESTful kind of thing, and assuming that there isn't cross-site request forgery protection, then what they could do is they could, for example, ask that you be logged out of Twitter in the second iframe. Okay? So your DMs are still sitting here. They were still loaded. So they're just sitting there waiting. If you clicked on anything in here, it wouldn't load because you're now logged out. Okay? But they are sitting there. They're sitting in the DOM tree. Okay? So they are sitting there. So what they do in the second iframe is they log you out. Then they open, you could do this in just one iframe, but just for clarity, I expanded out. Then they open another iframe, and now what they do is they log themselves in, the adversary. Okay, so the adversary is going to log in, and they're going to look at their profile, and they're going to look at their profile that has their bad cross-site scripted injected into their profile. Okay? So their malicious script is going to run in this third iframe. Okay? So first iframe has your DMs. Second iframe was just logging you out. And third iframe has a malicious script running in it. Okay? What origin is this malicious script? So the origin belongs to the iframe. The iframe belongs to Twitter or whatever social media it is. Okay? So this is running with origin Twitter. Okay? It can't reach out. It can't reach out of this into evil.com, okay, because it's isolated. But could it reach from this iframe into the first iframe? Why? Same origin. They're running on the same website and they're the same origin. Okay? So this bad script could reach in to this first iframe. What's sitting in the first iframe? All your DMs or whatever, right? And they're sitting in the DOM tree, like it's HTML, like they're text. It's text, right? It's HTML text. That's what they're seeing. And so this script can access the text that is being displayed here, whether it's even visible to the user. This iframe could be like 1 pixel by 1 pixel, so the user doesn't even see it. But this stuff here is HTML, and whatever's sitting there, the script could reach in and read. Okay? It can't go in and start clicking on things. It has permission to, but when it clicks on something, then Twitter will say, oh, you're not logged in, right? You're trying to access something that belongs to Alice, but the person that's currently logged in is not Alice. Okay? Now, you could launch more iframes, because once you get your script embedded in the page, it's running now. So then you could log yourself back out, and then, but you wouldn't be able to log the user back in. But anyways, and you could also load 100 iframes in the first step with all the different pages that you want to look at, right? And have them sitting there, then log the user out, log yourself in, get the script running, and then you could siphon all the information from all those iframes. Okay, so this is a sort of very elaborate attack, but it shows you like sort of the extent that people will go to, adversaries will go to, in order to do attacks. Yeah.
So how can everything run on one iframe?
How can which?
How can the attack run on one iframe?
It would actually require two, I guess. Yeah. So you could merge these two iframes together, but you would have to have the user data sitting in one and the adversary logged into the other account with the script in a second one. Yeah.
So the first frame icon has the victim's account.
Yeah.
With the second you log out.
Yeah.
And with the third you log in with your own account.
That's right.
So how does so once you log in, how can you
See the other people's DMs.
yeah.
Okay. So the idea here is this iframe doesn't refresh. So once you log out, if this iframe refreshed, then it would display a login screen, right? So the attack is banking on the idea that you can pull those DMs and have them just sit there waiting, but you can't access it quite yet. So you do the log out, you get your script running. Now your script can go and access them. So they have to sit there for it. Now, Twitter could have some JavaScript here that auto refreshes every 10 seconds, okay? But even that probably wouldn't be enough because you can do this almost instantly. And so, yeah, so I think you're pretty much, it's hard to think of how you could defend against it. I think this information would more or less be sitting there by the time the script got running.
But in the second item, once you log out,
Yeah.
is the session cookie not cleared?
Yeah, so let's think about what does it mean to log out. So the user sends a message to Twitter with a cookie, yeah? And because Twitter recognizes the cookie, it's happy to send the DMs into iframe 1, okay? In iframe 2, you ask to log out, okay? So what Twitter should do on their back end is they'll see the same cookie coming from the user, and what they'll do is they'll set the cookie in their backend database into a logged out status. So any future messages that come with that cookie, they won't send your DMs directly to you. They'll send you a login page. Yeah? So now you can't access anything else from that user's account. Yeah? Then what you do is you ask to log in with a different URL. They'll maybe give you a different cookie because you have a new session now. And that's fine. and then you'll run your script. And right now the adversary is left logged in, so the adversary has its cookie. Any future requests to Twitter would come with the adversary's cookie. So that's why the adversary can't start clicking on things here, because when they click on it, they request something, but it's the adversary's cookie now. And so Twitter won't show them anything else. So they have to get everything they want to look at loaded in the first iframe. They have to have it sit there and not get refreshed, right? Then they have to do the switch, and then they can access it. Does that make sense? Okay. Other questions? This is the most complicated thing you're going to see today. Okay. All right, so we call this a self-inflicted cross-site scripting attack because you're infecting yourself, but then you're able to get it shown to someone else. How do we stop this attack? So refreshing, we sort of played it out, but I don't think it works. I don't think you could refresh fast enough. Otherwise, the websites would be always refreshing, and then that's bad, like even when you're going there for a reel, and you don't want that. You don't want to generate all of that traffic.
We should not allow, maybe, I'm not sure, but not allow 2 iframes from the same.
Yeah, that's possible, but the website itself, like Twitter doesn't necessarily know that these are 2 iframes on the same page. The browser could do that. It could not. It could try and lock it down, but there's probably lots of use cases where you might want to load multiple iframes from the same website.
Yes.
Okay, so you can always log out, so that's fine. But users, we don't like to log out.
Blocking the information that only you see, like that you can show to the rest of the users.
Yeah, but how would you do that?
That's
Sure.
development program.
Yeah. Okay. So how do we get to that? The simplest way to stop this is actually on the very first step. So the first step is I create an iframe, and because the user's logged into Twitter, then it populates all of their messages in the iframe. How do we turn that off? So this is a cross-site request, right? So what we could do is we could require the URL to have the cookie of the user. That would require evil.com to have the cookie of the user to put it in the iframe address that's being loaded. Okay, and because of that, then they don't have the cookie, so then they could never load this frame in the first place. All right, so your basic cross-site request forgery protection. This is basically, it starts off as a cross-site request forgery, in a sense. In the sense, we're not trying to get you to follow someone else. We're not taking an action in your name, but we are pulling in your information into a frame. So if we can stop that cross-site request from happening in the first place, then the whole attack falls apart. Okay. Questions?
So Professor, we assumed in the first place, we assumed that the cookie is going in the, like, not as a parameter, but in the header.
That's right, yeah. So when we first walked through the attack, we assumed that there was no protection against cross-site requests. Yeah. Okay, another thing is, so here we have a website, evil.com. We have an iframe, and we have this Facebook like button that's in the iframe. And if you click the like button, then it will, the iframe is set up so that evil.com's article will, Facebook will learn what article you're looking at. It will post maybe a copy of it to your profile, and it will say that you liked it. Okay? Now, notice that this is a good use of cross-site requests. So you should be able to embed something like a Facebook like button on any website. Okay? And Facebook doesn't care from a security perspective because they know that the outside website can't reach into the iframe. Okay? So if I click this like button and I'm actually logged in, it will actually change my Facebook profile. This number, like 91 friends like this article, that's real. Those are my real friends, and Facebook is putting that number there. This website doesn't know who I am. It doesn't know that I have 91 friends that like this article because it can't read anything that's in the iframe. Okay, so far this looks good. This is exactly what we want. We want to be able to embed useful things from other websites into our website. We want to have isolation between the elements. The other websites don't want to put personal content in if the website can read it. So it's a very safe way of embedding information. Okay, so this is exactly how iframes and cross-site requests should work. Okay, now what the adversary wants to do is they really want to reach into that box and press the like button. Okay, why can't they do that? Why can't they, if they can run any script they want, why can't they just reach in and press, like not like move the cursor over it and click down on it, but like press it in the sense of like whatever, when you press the button, it fires off some JavaScript. So why can't the script here just ask for that JavaScript to be fired off?
Because the iframe is in a different origin.
Okay, so the iframe is at a different origin. So the website, everything outside the website has evil.com frame. Everything in here is from Facebook. Even if I found a JavaScript that was hosted on Facebook.com and I pulled it into the evil.com, right? That JavaScript doesn't have access to the like button, right? Just because I pulled it from Facebook. So that's why the same origin is set up the way it is, right? When I pull it in, it's going to run with the origin of evil.com. Okay, so is there anything I can do to get you to press that like button? More or less what I actually now I need the user to press on it. Okay, so as an adversary, I have no way of pressing the button, but I need the user needs to actually press that button. Okay, one thing, what's the one thing I do control? Okay, so I do control my website, and as it pertains to this Facebook like button, what do I control about it? So I control the frame itself. Okay, so I chose to put the Facebook like button inside this frame. I chose where the frame is on my website. I chose how big the frame is. So everything about the frame itself, its placement, that's under my control. But it's, as far as what goes in the frame, it's a black box. I chose that Facebook's the one that's allowed to populate that black box, but then I can't see anything else. Okay? All right. Now, I do control the rest of the website, okay, outside of the iframe. What does that mean, outside of the iframe? Okay. I guess it could mean two things. The thing that you probably are thinking it means is it means outside as in like geometrically, like in terms of this interface, like this is inside the box and this is outside the box. Okay, so in terms of like the number of pixels on this screen, all the pixels inside the black line are controlled by Facebook, and everything outside the iframe is controlled by the website. Okay, that could be one definition of what it means to be outside the box. But browsers don't actually care about pixels and things like that. They care about logical isolation. Okay, so to them, an iframe is something that's on the website somewhere. Okay, they don't really care about where it is. And all they're saying is that everything that was put into the iframe in a logical sense, like all the resources that were loaded by the code of the iframe, are going to be inside the iframe and everything else is going to be outside. Okay, but they don't see like geometric boundaries or anything like that. Okay, so what can you do? What you can do is you can take a picture and you can put it anywhere you want on the website. Okay, I control the website. I control evil.com, and so I can lay out my website in any way that I want. Okay, so what I could do is I could take claim prize as a picture, and I can put it over where the iframe is and right over that like button. Okay, what happens if the user comes along to this website and they click claim prize? Okay, so there's a chance that they click on the like button. Okay, now there's only one problem, which is when you click on something, let's say you have things that are layered on top of each other. Like say you have two buttons that are layered on top of each other and you click there. Are you clicking the top button or the bottom button? Are you clicking both? Okay, so by default, you would click kind of the top thing first. Okay, so that's the default setting. So if I click on that image, it's like I'm clicking on the image itself. Okay, but HTML is very flexible. And so what it does is it allows the developer to define the behavior themselves. They say, we're not going to make those decisions for you. If you want to put two buttons on top of each other, you can decide. You decide you want the top one to click or the bottom one to click, both of them to click. That's up to you. Okay? And so what you can do is you can load a resource and you can set the transparency of its click. So you can say this has a transparent click, which means if the user clicks on it, it just passes through. Okay? So then it would just pass through to whatever's underneath if there's something underneath. Okay? So that's what people do is it's because HTML is so flexible and it gives the developer lots of control, you can put an image over top of an iframe and you can make the click transparent on that image. So if the user clicks on the image, the click goes through the image to whatever's underneath, and the thing that's underneath could be from a totally different website, and you don't even see it. Like the evil.com doesn't even know that it's there. It doesn't see it. It knows it because it can load the website and look and see when I go to the website, this is what I see. Okay, so this is called click jacking. So like hijacking a click. So the click is transparent. It clicks to what's ever underneath. And then if the user's logged into whatever's underneath, then because of cross-site requests, it can do whatever you can do through cross-site requests. Whatever you can pass into a URL, you can do. Okay? So you might be able you could at least like an article. You might be able to post something. And so there was a period of time where, this is probably about 10 years ago, but people would log into Facebook and they'd be like, oh, my Facebook got hacked. Right? It got hacked because there was all sorts of weird articles that were posted on their profile, right? Chances are they weren't really hacked. It's not like someone went out and got their session ID or got their password. Chances are they just fell victim to this cross-site scripting attack, this clickjacking attack. So they clicked on something, they thought it was something else, and then that gave permission to the website to post a bunch of stuff to their Facebook. But if they go and delete it, it's not going to reappear unless if they go back to the malicious website. Okay, so this is sort of a one-shot attack where you get to deface someone's profile, but then it's not like you have persistent access to it. It's not like you broke their account, but you got access to it. Okay, again, how do we solve this? So you might say, well, we can solve it through cross-site requests, like throwing the cookie in. Okay. There's only one problem with it, which is that in this case, this is technically not a cross-site request because this iframe is owned by Facebook, and Facebook put the like button here. Okay, this isn't the adversary is not making a fake like button out here and having you click on it and have your cookies get sent along. This is Facebook themselves. So they're going to put this like button here. They're going to put your cookie at the end of the URL that's wired up to what happens when you press on this like button. Okay, this is not a cross-site request because it's in an iframe, so it's a same-site request. Facebook controls this iframe. Okay, so the way you get around it is actually you go back to the browser and say, this transparent click thing is kind of sketchy. And basically no one uses it. There's no real good use case for it. And so browsers will disable things like transparent click, or they'll get spooked. You can get extensions and stuff that look for this kind of stuff, and then they don't do it. Browsers might have rules about being able to place things over iframes, or maybe Facebook themselves, because they're populating the iframe, they can throw some policies into their HTML, and they can just say, look, I know I'm in an iframe. Don't let the website put anything over top of me. Okay. So anyway, so that's how we've sort of deal with these attacks. So we can't deal with it directly, but we can deal with it indirectly. Okay, so what are some lessons that we can learn from both the cookie policy and the cross-site scripting? So it's hard to get these policies right. You don't always envision how people are going to use, for example, people in 94 didn't really envision the modern web where you're weaving content together and everything is JavaScript based and things like that. So it's hard to get that policy right in 1994, and we've seen it. Fundamentally, there's nothing, it's not that the policy was wrong per se, either the same origin policy or the cookie policy. It's more or less the same policy today. We didn't change the policy itself, okay? Where the problem was is that developers thought one thing and the policy was a different thing, okay? And so there was a sort of learning curve where developers had to get the right mental model of how it works and then develop frameworks and things like that for other people to use that implement the right mental model. So we were able to get past all of these attacks without really changing the policies themselves. There's no great methodology that would find you vulnerabilities like say cross-site scripting vulnerabilities in your website type of thing. There are some tools like you can try and do static analysis or things like that. There actually was one paper that was quite interesting where they modeled the browser's policy in a formal language. So they basically turned the policy into code and then they asked some questions about the code. Like, is it ever possible for this to happen? And then you can't, programs like this can't say, it's too computationally complex to explore everything. But they are able to explore a large search space of things that are possible. And so they actually found some vulnerabilities using that type of approach. So the formal methods is one type of approach. But if you make a mistake in modeling, or you make an assumption, or you assume something is simpler than it actually is, then if your model's wrong, then the output is going to miss things as well. Okay? So that's always the sort of flip side of doing some sort of formal analysis. If you get the policy wrong, it's hard to go back and change things. You're going to break a bunch of things that were implemented under the old model, and those people aren't going to be happy with you. So browsers are reluctant to change things, but they will change things, okay? Or the browsers don't always work as a team. A lot of times what I've observed is Google is more proactive on security than the other browsers. And so Chrome will just announce, hey, you know what, we're turning off JavaScript served over HTTP. You have 2 years to fix your websites, and this is the date. And on this date, all Chrome users will your website's going to break for all Chrome users. Do what you want, right? And then usually, all the websites are going to update because they don't want to lose all their Chrome users. Some of them don't. Maybe they don't realize it. Then they start getting emails from Chrome users saying your website's broken, right? And then they fix it right away. And there's always some websites that were put up by someone that's not maintained, and then those ones die and no one fixes them. But in general, it's sort of a rough period, but you get through it. And then developers, we've seen some examples where you set the cookie permissions to the most permissive thing. You set origin to the most permissive thing. So developers often are, they just want it to work, right? They're getting some weird errors. They want it to work. You go to Stack Overflow and you find some post where someone else has that error, and the top voted answer is, well, just set your cookie domain to the highest level that it can be, or set your document origin to the highest level possible, and then now things will start working. Your scripting will be able to see each other and they'll be able to talk to each other. Okay, that's not good for security though. Okay, we want developers to actually, the security principle is least privilege. So we want them to lock things down as much as possible while still letting it work. But what ends up happening is that developers, instead of struggling with why is this error actually happening and how can I override it and how can I punch out a specific case so these two things can talk to each other rather than letting everything talk to everything. They're not willing to put in that work, and it's confusing. And so you just go for the default solution, and then all of a sudden it works, and then maybe you're like, I'll fix it later. I'll add security later, but then you forget about it and you never fix it. Or you fix it when it's too late because there's a problem with it. And now we have, the web languages have expanded, and browsers now allow like more custom policies and things like that. And so people can set policies through some new sort of policy languages that browsers will interpret. But so this is good. I'm not saying it's a bad thing, but every time you give more customization and control, it also increases the complexity. And so it becomes harder for things that you want to interoperate to actually interoperate. And so people will just sort of turn this stuff off. Or you might get it wrong in terms of how you specify it. So you might be thinking that you're fixing a security flaw, but you're not actually fixing it and things like that. So customization is good, but it's, you still need developers to have the right mental model now of something that's more complicated than what they had to before. So there's no getting around the second point. Okay, so today was sort of a short lecture, and so that actually officially ends the content of the course itself. Is there any questions about the slides first, and then I'll answer whatever questions you have about the exam.
Because I wanted to ask if an iframe cannot be adversarially controlled, like it's a black box to the adversary
Yep.
on their website, then how does the adversary make the user log out and then log in again?
So we're going to assume that they can pass that through URL parameters. So we can send a parameter like sign out equals true, and then it would log them out. And then similarly, if we wanted to log in, we could pass it through a parameter like this. So that it's an assumption that we're making. So if the website weren't coded in that way, then this attack wouldn't be possible on that particular website.
Yeah, and same for the script also that we run. The adversary is running in the third iframe.
Yep. What do you mean by the same? So it.
It's the same thing that applies to the script.
So the URL parameters apply just to when you load the iframes. And then the assumption we're making about the script is that we were able to put it in like some part of the website that would only get displayed to us, that wasn't protected against cross-site scripting. So instead of writing foobar at riseup.net, I was able to put a full-fledged JavaScript in there. And then when I say, what's my email address, I want to change it, it says, well, your current email address is, and then it starts running the script. Yeah, so that's the script that we're running, or sorry, that's all we're assuming about the script itself. So then you get the user who's on this website with their profile details already loaded, running the script that they're actually on your profile, logged in as you, looking at your profile, running your script. You don't care because it's some garbage account that you created just for attacking people. And then because the script is running here, it can siphon whatever's already been loaded in any of the other iframes. Yeah. So the attack is like, it's not like it's very limited. There's a lot of assumptions that you have to make for it to work. It's not like it's going to work on every website. It's limited in terms of what you can do, but it still violates something that you shouldn't be able to do that. You shouldn't just be able to click on a link and have all your DMs, on Twitter disclosed to the person whose website you're on, right? Like that's something that should not happen. And yes, you have to have a lot of assumptions to make the attack work, but there is at least one way that you can jump through a bunch of hoops and have that work. Yeah. Yeah.
So having an image over the iframe
Yep.
with a different transparency, is it possible to embed a link or something malicious in the image while it's still being on the iframe?
Yes. Yeah. So first off, even though I'm showing it as like visually transparent, that's sort of an analogy. So here the click is transparent, but the image is fully intact. Okay. Now, images can carry links as well, right? So you could have a link to anywhere you want on the image itself. But once you set the transparency of the click, when the user clicks on it, instead of going to the link that you set, they're going to go to whatever's underneath. So
Can it be flipped?
yeah, so you can have, sure, you can put an image over top of something with a link to wherever you want to go. Oh, do you mean can you put it underneath?
Yes, like okay, like having an iframe
Yeah.
with an image of a malicious link, then
Yeah.
having Facebook over it.
Yeah.
So
I understand what you're saying. Okay, so can you do it? You probably can. I'll walk you through why. But the thing is that there's also no point in doing it. So the point is, if I want to trick you to going to an arbitrary link, once you're on my website, I can just send you there directly. I don't need you to click on something. I can just open up a connection to that website anyway. So once you're on my website, I can make you send any request just through my own JavaScript that I'm running. Yeah, so I don't need to put it underneath like a real Facebook like button and have you click on it to get you to go to that link. I can just send you there directly, if that makes sense. And then secondly, it probably wouldn't work because it would require Facebook to program a transparent like into their like button. So you could indeed put an image sort of underneath the iframe, but you can't change how Facebook coded their like button so that it would click through their like button to the thing that you put underneath. Yeah, so that would require Facebook to change. So it probably isn't possible, but like I say, there's no point to it because once you have them there anyways, you can get them to go to the link without clicking on it. Okay, other questions? Okay. So the exam, I don't have anything really new to say, but I'll just sort of say the things that I've already said. So I did post the rooms. I mentioned this already. So there's 2 rooms. Depending on what your last name is, you'll go to one of the rooms or the other. There'll be a sign-in sheet for them. I myself will rotate between the rooms. So you'll have access to me. I can't be in both rooms all the time, but I'll go back and forth between them. There'll be invigilators. They don't know anything about the course. They're not even necessarily even in CISE. They're usually engineering students, but they might be in some other faculty. They've never taken the course. So if you have questions, you'll have to wait for me. I'll be the only one that answers them. All the other kinds of instructions I'll give you on the day of the exam itself, but basic things like you can't talk to other people. Even if it's like asking someone for an eraser or something like that, you have to put your hand up and you can ask the invigilator to ask them for the eraser. And, well, you can have the eraser, you just have to do it that way. You can use the washroom anytime you want. You can bring a cheat sheet. So whatever you want that you are scared that you're not going to be able to memorize, write it on a piece of paper, just like one sheet of paper, like a letter size paper. It can be front and back. You can write it as small as you want. You can use a magnifying glass. Doesn't matter. The reason it's limited to one sheet is just so that people aren't rifling through books and like moving things around. It just gets really loud. So it's one sheet there, and you can look at it. And there'll be short answer questions. There'll be multiple choice, probably mostly multiple choice. And the multiple choice you'll do on a Scantron. So Scantron's like with the little bubbles. So you'll answer on the Scantron. So at the end of the exam, you'll hand in your question sheet, which will have short answer that you'll write directly on. And then you'll give me the Scantron as well. The Scantron will be marked by a machine. And it likes when you use pencil, and it doesn't like when you use pen, even if the pen is dark. So try to use pencil if you want it to actually read your exam. If you use something else, usually I get an error message back, and then I have to get your physical paper and look at it. But anyways. If English isn't your first language and you want to have an English dictionary, that's fine. And if you feel comfortable having a calculator, I promise you're not going to need it, but if you want to have it anyways, you can certainly bring it. The questions will be conceptual. So I'll try and think of like a new scenario that uses one of the principles that we learned in class and ask you about it. I'll ask you to apply something we learned in class to something that you haven't seen, like a new scenario. That's the type of question I like. It doesn't mean every question is going to be in that nature, but that's what I try to do. And so the best way to study is to really understand the concepts, like, and don't give up. Like if you, like you're looking at that attack that we just looked at and you're like, I really don't get it. Like you need to understand it so that you can recognize it in a totally different context on the exam. So that's the best thing. So there's no, you don't have to memorize anything. Anything you want to memorize, you can write on your sheet. It's really just being comfortable looking at every slide and just saying like, yeah, I know what's going on in that slide. I could explain it to someone else, and then you should do well in the exam. Usually, like I say, the best students usually leave they might leave in less than an hour, like 45 minutes or an hour or something like that. So if you understand the concepts well, it shouldn't be a hard exam. If you're shaky on the concepts, you will find it difficult, and often there'll be a couple answers, especially on something like multiple choice. Like all answers will look reasonable when you read it for the first time. Hopefully, if I do my job correctly, then it's not going to be like one of those exams where it's obvious which is the right one. You're going to read all of them and think, oh yeah, they all sound right, but there'll be one that's right, and it's not going to be like subtle differences. Like they'll just be sort of completely different things, but still like kind of reasonably sounding. So, anyways, that's the sort of the nature of the exam itself. Questions?
Do we have any open-ended question?
So the short answer could be open-ended. So I used to, one question I used to ask that I won't ask you because we don't cover it anymore is, we used to have 13 lectures instead of 12. So the 13th lecture that you're all missing was on ethics. So I would just say, what was your class project on? And tell me like 3 ethical dilemmas in your class project. That kind of thing. So that's an open-ended question. Every student's going to answer differently because everyone's doing a different thing. And so that would be an example. So that's possible. I might do something along those lines. It won't be about ethics specifically, but that's an example of an open-ended question. So it's conceivable. I used to have people like draw like attack trees for something, but it just, that one is too hard to mark. Everyone has a totally different tree, and I have to spend a lot of time looking at everyone's tree and trying to mark it and think through it. So probably won't ask that one. I won't ask it now that I told you. But that's another example of a more open-ended question where students there was no right answer. There's right answers, and as long as you got something right, it was fine. But yeah. The multiple choice, though, is very unforgiving. Like there's a right answer and everything else is wrong. And so that's just what multiple choice is, right? Sometimes students get excited by multiple choice, and it's good and bad. Like it's not better or worse. Like the worst part is that there is only one answer. There's one right answer. If you don't get the right answer, then you get 0 basically. Even if you know enough, even if you know something about the question, not enough to answer it correctly, but you do know something, it doesn't measure that partial knowledge that you have. So that's the bad side of multiple choice. The good thing is if you absolutely have no idea, you have a 1 in 4 chance right out of the box. And then if you can think about it, you might be able to get, a 1 in 3, a 1 in 2 chance. And that's really good. Like, it's good to have that advantage, right? So that's why students like multiple choices, because you have the ability, and if you're clever and think about like the answers themselves and whether they could even be possible and things like that, you might be able to reverse engineer what the answer should be. So you have a chance. Whereas if it's short answer and there's a blank piece of paper and you have to write something and you don't know what the question's asking, then you have no chance at all, right? So both of them are like, yeah, anyways. But of course, all of you will know everything, and so it doesn't matter to you whether it's short answer or multiple choice, because you'll never be guessing anywhere on the exam. Okay, other questions? Yeah.
So the multiple choices, they're going to be dependent on a scenario as well, right? Or is it going to be the scenario is going to be short question?
It could show up in either. So it could just be like pretend, Alice goes and does whatever, and then there could be some multiple choice about it. Yeah. So that's like a common kind of question that I'd ask. Usually the short answer are more, they're more about, it's a kind of question that if I could ask it in a multiple choice format, I would, because it's easier to mark, right? So they're usually questions that require something that isn't easily expressed in multiple choice, right? And it's also an opportunity to get part marks and things like that for students.
So what's the limit to short answers?
What's the limit?
Yeah.
Like, limit in,
Marks, like, can you give 3 sentences? Can you give 2 sentences?
yeah, so usually think about, you'll look at a short answer, and let's say it's 4 marks. I'm looking for 4 things. So think 4 sentences, 4 marks, 2 marks. If it's 2 marks, it's 2 sentences. Usually it's pretty clear. Like it might say like, here's the question, what's the answer, and explain, 2 marks. So then it's sort of like you get 1 mark for the right answer and 1 mark for the explanation. But if there's multiple marks for the explanation, I'm usually looking for multiple things. But usually I try and make it clear in the question, like tell me 3 things, right? And then it's worth 3 marks. Like I don't think there'll be much confusion about it. And usually a mark is no more than a sentence. So you don't have to write a paragraph or a page to get a mark. You usually, it's just an idea, and it can usually be expressed in a sentence.
So are the marks on each question?
Yeah. So most short answer questions would be something like between 1 and 4 marks. So like the biggest short answer question would be like a 4-mark question where I'm looking for 4 things. But usually if I can split it into multiple, like if I'm like, okay, tell me between this and this, then tell me the reason for this, then tell me the reason for this. Like I'll try and break it down. Like I'd rather give you 3 shorter questions and answers than one big one that's the same. It's asking the same question. It's just doing it like in one box kind of thing, right? So what I'll do is I'll break the question down as far as I can, and I'll give you a box to fill it in. The exam sheet will have like a text box, like a space to write the answer, and that will also give you a sense of like the sort of length of the output that I'm looking for. Yeah, but usually it's like less than a quarter of a page kind of thing, like it's just like I'm usually just looking for a sentence or 2 kind of thing. Now, along those lines, 2 things. 1, you need a pencil anyway for Scantron. You can write your whole exam in pencil. So some students think that, I don't know, you have to write in pen because it's permanent or something like that. You can write it in pencil. You should write it in pencil because then you can erase things. Okay? And if you run out of space and you didn't write it in pencil and you can't erase it, you can like, as long as I can find your answer, it doesn't matter. Like you can write it on the back of another sheet or in the margin or whatever, as long as you sort of point me to where it is, then it's fine. I'll find it. So. Okay, other questions? All right, so seeing none. Thank you for the course. I don't know if it's too late to do the course evaluations. You would have got an email about that, but please take the time to do it. Any feedback you have for me, it's anonymous. I can't read it. And I do actually read it and I change things. So for example, you are looking at slides this year. In past years, it was handwritten. I changed it because students asked for it. There's a recording of every single lecture. Why is there a recording of every single lecture? Because students asked for it. Okay, so if you ask for things, if it's within reason, I definitely will make changes based on feedback. So that's a way to give feedback. Since we studied Lacquered scales, the course evaluations are weird. Like usually like 5 is good and 1 is bad, but here it's the opposite. So every year there's a student that gets me all 5s, which is actually the worst possible thing. And I never know, I'm always like, did they hate the course or did they just like not look closely at the Lacquered scale? It's always a question mark in my mind. But anyways, you just pay attention to that. It might be too late. I don't know when the cutoff is for it. But anyways, and the instructions are here for how to fill it out. Okay, so good luck with everything. I will still do office hours this week, and I guess I can do them next week too because it's before the exam. So if you have questions, I'll try and remember. If I'm not there, just send me an email to remind me. But you can also email me or message me on Moodle or whatever if you have questions going through the material. And yeah, good luck, everyone. Thanks.